All right, let's look at another example of how changing the amounts of reactants or products might change things up, right? In the second example, it says, suppose some hydrogen is removed. So what that means is our hydrogen concentration is going to come down. Let's picture our teeter-totter in balance. And if we remove some hydrogen, so it's in balance, but pretend like those are little kids sitting on that teeter-totter. If we took some hydrogen, which is on the left-hand side, we took those kids away. Now suddenly the NH3 side of our teeter-totter is going to be heavier because there's no hydrogen on the other side to balance it out. So our teeter-totter is going to look something like that instead. So kind of lean like you're on that teeter-totter. Put your right ear closer to your right shoulder. And now we have to fix ourselves. We have to get ourselves back in balance. So in order to fix ourselves, you'd have to tilt your head to the left. Well, if we're shifting to the left, that means the reverse reaction is suddenly going to happen in overdrive. Well, we established here what happened to the hydrogen, but we have to talk about all the other stuff. So what happens to everything else? Our nitrogen concentration is going to go up. We're headed towards it. The reaction says, you took away my hydrogen. I have to try and fix that. I have to try to make more. So it goes to the left to try to produce more hydrogen. And just as a byproduct, you end up making more nitrogen at the same time. Our NH3 concentration is going to come down because we're moving away from it. And because we're moving away from that heat energy, it's going to feel colder. Some other stresses that might occur are with temperature changes. So if we look at reactions, or steps number 3 and 4 here, our stress in number 3 says, suppose we took this reaction and we put it into an ice bath. In other words, we made the temperature come down. The reaction says to itself, it's too cold in here, I have to try to warm myself up. So the way it tries to warm itself up is by producing more heat energy. Since the heat is on the right-hand side, it's going to shift to the right, where that heat is, to try and warm itself up. So we talked about the energy component, now we have to talk about all the other things. So our nitrogen is going to decrease. We're moving away from it. Our hydrogen decreases, moving away from it. But our ammonia would increase since we're moving towards it. If we look at number 4, the opposite is taking place. The stress, we're increasing the temperature if we put it in a Bunsen burner flame. So if we increase the temperature, the reaction says, ugh, it's too hot in here. I have to try and get away from this heat energy, so it's going to shift to the left. You don't want to shift to the right and produce more heat energy. That would only make the problem worse. So it tries to get away from it. Well, if you're going left, your nitrogen and hydrogen concentrations are both going to increase. We're heading towards them. Your NH3 concentration would decrease. We're moving away from it.